Assalamualaikum and salam sejahtera. Today we will discuss in our SFEE devices, and our last topic is about throttling valve. So if you can see here, this is a throttling valve. So what is throttling valve? Throttling valve is a flow, any kind of flow restricting devices that cause a significant pressure drop in fluid. So if you can see here, this is a schematic diagram of a throttling valve. This is the inlet, and we can see here that the pressure at the inlet is greater than pressure at the outlet. So we can say that the function of throttling valve is to decreasing the pressure. Throttling valve is usually a small devices. So the characteristic of throttling valve, we can say that it is adiabatic, potential energy is negligible, as well as kinetic energy. Since there is no fan here, so we can say that there is no work done. How about the SFEE? Okay, with all the characters, we can reduce the SFEE to this equation. Okay, so from this equation, we can see that the enthalpy at the inlet of throttling valve is equal to enthalpy at the outlet of throttling valve. And then we can expand the enthalpy equation to U1 plus P1 V1 is equal to U2 plus P2 V2. Okay, next we go to the example of the throttling valve. So if you can see here, a refrigerant 134A enter the capillary tube of a refrigerator as a saturated liquid at 0.8 megapascal and is throttled. Throttle means to reduce, okay, to pressure of 0.12 MPa. Determine the quality of the refrigerant at the final state and temperature drop during this process. So, if we can solve this problem, first thing first, we have to sketch. Okay, I always like to sketch first. Okay, so this is the capillary tube of refrigerator. So this is a throttling valve. Okay, so R134A. Okay, this is state 1 and the other side is state 2. Okay, so what is state 1? State 1, it has a pressure of, so I write down it as a state 1. It has a pressure of 0.8 megapascal and phase is saturated liquid. Okay, so we already have two property. Therefore, we can refer to table A12. Okay, so from A12, I just refer to pressure of 0.8 megapascal, which is about 800 kPa, and I look at the HF because the phase is in saturated liquid. So HF is equal to H1, and I get from the table 95.48, and the unit is kilojoule per kilogram. Okay, and also from this table I get the T saturated is 31.31 degree Celsius. Okay, so how about the state 2? Okay, so we look at the state 2. State 2, it has a pressure, the pressure drop from 0.8 to 0.12 megapascal. So it has only one property. But if we want to refer the property table, we must have at least two property. So since there is 1, how can I get the value? So please remember that from this equation, H1 is equal to H2. Okay, so based on that, I know that H2 is equal to H1, that is 95.48 kilojoule per kg. Okay, so I just sketched the TV diagram because I want to know what is the phase at the state 2. Okay, I sketched the TV diagram. Okay, this is 120 kPa. Okay, from table A12, I get HF. Okay, I get the value of HF, and the value is 22.4749 kilojoule per kg, and Hg is 236.97. So given here, H2 is 95.48. So it means that the value of H2 is in between HF and Hg. So the phase is saturated mixture. Okay. So since since at the outlet is saturated mixture, the question asks about the quality of the refrigerant. So how to find the quality? Please remember, for mixture we have special formula. So since we have enthalpy, then we can get the quality from this formula. H2 is equal to HF plus X HFG, right? And then X is equal to H2 minus HF over HFG. Okay, I refer to A12, table A12, and I get H2 as a 95.8 minus HF 22.49 divided by HFG given from the table is 214.48. So I get the quality is 34%, or you can give in decimal, okay, 0.34. Okay, so that is question number 1. The question number 2 is about the temperature drop, means that we have to find delta T. So delta T is T2 minus T1. So again, we refer to A12 and we look at the properties given at the state 2. Okay, and from the table we get T2 is minus 22.32. Okay, degree Celsius. So where I find the 22 here, T saturated. Okay, minus 22.32. Okay, then minus T1. T1 we get from the table is 31.31 degrees Celsius, and then the answer is minus 53.63 degrees Celsius. Okay, as simple as that. Thank you.